Hi everyone. I want to take a slightly more conversational take on this video. One of the things that I've been doing is showing you a somewhat atypical way to think about programming and mathematics. Neither one of these is strictly common mathematics nor strictly common programming. My goal isn't to change the things we do, but to bring out the connections that maybe go unnoticed when we get trained classically in one area or the other area, but not in both. But it strikes me that I should tell you a little bit my own history so you understand where I'm coming from. I spent many years working in technology. Then I got lucky and got a job for Intel in high school. And there I was trained by a great mentor, Chris Genley. Shout out to Chris. In that role, I was taught various types of programming. And in particular, I got to work on projects that were for anywhere in the home. As part of the Intel architecture labs. The idea there was to design for the future. Imagine that chips are available at any kind of power you want, and you're 20 years into the future. What would a computer do? Some of the ideas that our lab worked on were to be able to walk into a house and just have a conversation with your house about buying groceries, finding some news article, tuning on the TV, and watching a DVD. Some of my efforts were to work with the speech interface and controlling the technology, such as TVs and DVD players. I was especially proud of working a microphone into a little remote control. These days, you all see these everywhere. This is 20 years later, and the reality is that that is everywhere in the home through products like Alexa. There were other projects that talked to a car that came out 10 years later in Microsoft Sync. And there was also a project that nearly made it to market called the Intel Web Tablet. I still have mine right here. It's an old version of an iPad about 10 years before the original iPad. You can see it's thicker and it has its own little marker. My job was to make this connect to the internet and stay connected. This was back in an era of dial-up. So you had AOL and other types of DSL. It was a very noisy environment, much more difficult than modern internet connections. So it was a challenge then, and I got to play around with the technology. All of that led to hundreds of thousands of lines of code. One of the projects that connected the home to speech had at least 100,000 lines of code that I myself had written. I was very proud of it, and I still am, but there was a certain part of me that started to realize there was no way anyone else could maintain this, and it was unlikely that many of those lines would ever get used by anyone except me, and even myself. How did this happen? Well, it was in a generation when programming was done in a different style. If I wanted to connect to the internet, I would make some particular class of object called Internet Connection Manager. Then I would think about everything that could ever be done with an Internet Connection Manager, and I would keep adding functionality to my program, adding new objects and new commands. Many of those commands were in anticipation of some future use. They would be a guess at what the future might want. I'd have some commands to write out text to a screen. Other commands to write text to a file. Other commands would put it in a stream. Each of these were repeating roughly the same steps. It's what we today call boilerplate. It makes code very large and hard to maintain. Similar steps get repeated with minor variations. It's easy to find a mistake that you fix in one place that doesn't get fixed in all the places that are similar. So while it was an exciting time for programming, we were connecting lots of technology together for the first time and the internet was starting to come online, we had not realized how we were making our software difficult to think about and to maintain. Anywhere in the home and the Intel architecture labs folded, I moved on and got a degree in mathematics. I'm now a professor in mathematics, and it affords me the time to think deeply about the questions that I care about, such as, what was I doing with hundreds of thousands of lines of code? Could I have done it with 10,000 lines, or even 1,000 lines? What was essential to that? I was once on a high school panel, and students were asking, what is the largest amount of code you've written? I'm not proud of the lines of code I've written. I'm proud of the 7 lines of code that I've written. Small packets of code can pack all the real impact. That's what I'd like to really pass along to you. And there's a reason for this. One thing is it's just difficult to maintain. The second one is that it's actually a huge head start. Imagine this. You're working in logic. Logic has history back to Aristotle and Plato. That's about 3,000 years of work. And add to that a lot of human experience, which has been logical even in other languages. That's a huge head start compared to just learning how to program in, say, C++ or Java. When you take your programming back to the history of antiquity and you link it to logic, you have a lot of lessons already learned in the can, ready to go. And if we realize that logic translates into very nice data types, they come in as minimalistic data types. And that's because logic has learned that the best arguments come from making sure that they're correct by linking together very small steps at a time. Don't bother to think about everything that a connection manager can do. Think about one step in that chain. Think about just connecting to the dial-up. Then from there, connect it to another component. Lots of small steps are then easy to reconfigure to an enormous complexity. Think about how atoms can glue together to make tons of chemistry. This is the model of programming that's most common today. It moves you away from boilerplate. It lets a mistake be fixed one place and then it percolates to all other places. Once you know you can program this way, you also have a library of places to look. Instead of looking for the latest API, you can go look and read a book on organizing logical thinking. Think about your problems in the language that humans like to talk to each other in. It's much more humanistic to think about your problems in logic than it is to think about them in some particular programming language. The programming language should be the last concern. You should think about how to organize your information in simple logical steps. Then you'll be able to translate it into whatever programming language your environment requires. It makes you a versatile employee. Go from one shop that does Scala to a shop that does Haskell to a shop that does Python. You'll be ready to change those techniques by just tweaking how you translate your logic. Now, all that said, 20 years later, I didn't anticipate many things, including AI and other technologies. So I hope that in 20 years, I'm learning from you. Until next time.